Good afternoon. I'm the last man standing between you and your lunch, so excuse me for that. And I will try to, go fast. And if you have any question and answer, then we can do it during the lunch or later on. So, okay. So we are a small startup called dDriven, and since we are not a big company like Accenture or SAP or GE, we will introduce ourselves first. So we are nearly 3 years old. It's another couple of months till our third birthday. So far we worked mostly in the process industry. That's our area of specialization. And what we do, we call it digital twin. But then there are many different incarnations of digital twin, and I will try to put a perspective to that. So far during these projects, and we come from actually exactly the same field, and which I'll explain you later. We have dealt with probably 50 different applications that you see in the oil and gas industry, starting from all kind of DCS and historians to all kind of MES systems that you see from Aspen and Honeywell and Schneider, Invensys and all that. And then at the higher layer, SAP, FICU, VM, SND and whatever. And also on your trading desk, the triple point, CXL, Bulldog and XYZ. So probably during our lifetime of 2.5 years, we dealt with about 40 TB of data and 50 different applications and probably 500 different application analytics use cases, right? We are right now 40 people of team, and we are growing very fast. Our headquarters is in Singapore, and development team, a bulk of the development team is in India, and then we have got people in Middle East, USA, and a solid representative in Korea who's sitting there. So this is the team, and on the left hand side we have a serial entrepreneur with whom we joined, and he is my classmate. He had been very successful and exited his first company to Schneider at a very large amount, and then 4 of us, we came from Siemens, and we kind of started this business exactly the same thing about in 2005 when these terms, industrial IoT, digitalization, digital transformation were not popular. And then there is a reason for which actually we jumped, and the reason we'll come across later on. So all 4 of us, we have spent our time in probably last 12 years exactly the same thing that we are doing today. And this is all about digital twin and digital transformation. And we have a different perspective to it, and we'll try to explain that. So now, sorry, here the animations are a little bit heavy. It's hot from the oven. So this is what we did from 2005, and we see actually the digital twin answers basically 4 basic questions. What's happening now, right? And then if something is wrong, maybe you are looking at your working capital which is going north, and you want to actually drill down from a very high level synopsis to your tank and analyze the dead stock and the money that's stuck in your tank. So that's we call an inside layer, which depends on a hell of a lot of modeling. The third layer is right now we have started doing it in 2005, or as a part of our last incarnation, is the predictive, what may happen. So this is where the predictive and prescriptive things comes, and I will give you some example there. And then what we found that in any large petrochemical or large refinery, there are many things going wrong, and you can't actually handle or tackle everything. So you need an economic perspective that whether your working capital is a bigger issue or the excess of oxygen in the furnace. So everything actually needs to be transformed probably to a time series in dollar. And if you give that perspective, it's much easier for somebody to make a decision. So that's the 4th layer, right? Sorry. So now, in order to understand connected plant, we need to understand the disconnected plant. And when we walk into any refinery or a petrochemical plant, we come across probably about 40 to 50 different applications. There is SAP, Honeywell, Microsoft, Oracle, and everybody else. And these connections, these applications and the data talk to each other through morning meetings, through Excels, through over emails and phone calls, right? And this is actually the status quo. So this is where we actually are starting from, and this also hints to a big opportunity that we are sitting on. If you just do a simple Googling, you will see that the manufacturing industry spends over $150 billion, the number varies between 120 and 150, in IT and OT per year. And this is both process and discrete manufacturing. I don't have a number from the process manufacturing. And if you take a summation of last 10 years, probably the manufacturing industry has spent about $1 trillion in IT and OT. And whichever plant we go, we see that they have at least 10 years of data sitting there, right? And this is a gold mine. And this is actually a big opportunity right now to turn into a connected plant. This is a real inquiry from a large hydrocarbon manufacturer in Korea. And here you can see the point. They're saying that they have got 39 systems and they want to digitalize. And if you go into the detail of the system, they say that SAP is one system. For us, actually, there is SAP, FICO, MM, PM, SND, and there are many others. So it's actually, we are talking about probably 45 different systems. And when we go inside, we will find another 10 systems. So usually, when people start saying that we have got 45, 30, 40 systems, probably you can safely assume there are 10 more systems. And the IT department sometimes even do not know. Actually, they are sitting in the maintenance department or in the reliability department. This is the genesis of the problem and also the core of the opportunity. And we are actually getting inquiries today where people are saying that we want to digitalize. This is a one-page inquiry, and then say now you define actually what does it mean. So there is a lot of awareness in the market about digitalization, digital transformation, and most of the manufacturers, large manufacturers, especially in the process industry, are sitting on a gold mine, and that's a huge, huge opportunity. Now, I did a Google trend search, and you can see that if you actually put digital transformation on a Google trend, from 2015 onwards, it's actually going high, very high, right? From 2004 to 2015, actually nobody really bothered. Now, this is the time actually we have been practicing our hand, sitting in a big company, and around 2016 we came out and formed a company which is completely focused on digital transformation into the process industry. Now, if you Google the word digital twin, the picture is very scattered. You will see a lot of articles, especially the new articles, and there are somebody talking about process digital twin, somebody talking about this and that. And it's extremely confusing there, because the digital twin was there a few years earlier, and you have to actually put that into a perspective. What are you talking about? Are you talking about the digital twin for an EPC company or the EPC phase, or are you talking about a digital twin for a running plant? They are completely different. The digital twin used by Bechtel and JGC are completely different for the digital twin you may use when you are running the plant. The tools, applications, and even the vendors are completely different in discrete and process industry. So you can't really have a very generic definition of digital twin covering all the life cycles between the EPC phase and the running phase, and between discrete industry and process industry. The digital twin is not only about data and IT technology and big data and artificial intelligence. It takes a hell of a lot of process expertise or domain experience. It's a marriage. So that's why actually it's very specific. Even within a discrete industry, somebody who is in a car manufacturing, he will not be able to actually conceive a digital twin in electronic manufacturing. So it's very domain specific. And we also see that somebody who actually is an expert, and he says that, okay, what is digital twin for a CDU, and what are the parameters like COT, CIT, blah blah blah, how do you set a virtual viewpoint and all that. they actually are, not expert in when we go into a company like LG and go into a petrochemical. So it's a lot of domain expertise actually gets blended when we talk about dDriven twin. So we have to put our perspective clear that we are talking about processing plants and we are talking about the processing plants when they are running. Right? And now the central question is that why we want to do digital transformation. Is it because we want to use big data, we want to use artificial intelligence, predictive maintenance and all? The answer is that we want to actually pursue performance excellence. And there is a big opportunity that we have been actually accumulating this data and 50 different applications. Right now the technology is ripe enough to leverage this data and change your performance benchmarks, whether it is availability, utilization, working capital, tide, whether actually it is actually predicting a dew point in your CDU or a perfect value for your, at every crude change the COT value or CIT value. This is actually possible through the technology, but the central purpose is performance management. Now, we've broken up the problem. We are building a platform, and we have broken up the problem that what is this performance management? So the performance management is the central question that what actually how I'm performing and how I may perform, right? Now, when I say how am I performing, if I throw you all your tags and all the anomalies that's there in your tags and say, oh, this tag is anomalous, this tag is anomalous, this has exceeded the envelope, this is a chaos. So the performance is defined in terms of KPIs and KOPs, key operating parameters, right? So that definition is, you have to start with the derivatives of all the tags or the data stream that you have, and then say that okay, these are the performance markers. So this is actually the starting point, right? Then we talk about the exceptions and excursions. You can't really scan like a radar all your KPIs and KOPs. So there is definitely a mechanism to go, look into the exceptions and excursions. Then there is a now part and then there is a future part. You are running a plant and the opportunity cost second by second, minute by minute is pretty high. So definitely there is a now part. What's happening? Is there actually an excess oxygen in the furnace, or is there something is leaking? Is a sealing in a pump is leaking? So there is a huge now part, and that has a huge opportunity cost. And then definitely there is a predictive part, which could be predicting a process parameter, it could be predicting an event like a maintenance failure, asset failure. Then there are various other questions that the system needs to answer. What is the context? Every exception, if I throw you, this has to be associated with the context when I explain. Then if I throw you an exception, I say that okay, you have a fever, but then you want to drill down and know that whether the fever is coming from dengue or typhoid or pneumonia, right? So there is a synopsis, there is a drill down to the details. And then there are many other issues. Now, whenever we go to a customer, they are doing some kind of a project. At this moment, there are a lot of initiatives. We have gone to came across a customer who had a budget of $2 million, and they have actually rolled out a Hadoop cluster, and then got stuck that they could not get the Honeywell PhD data into the Hadoop. And they said that we said that why you do that? He said that we have a budget and a target to do big data analytics. So we rolled out our Hadoop cluster, we brought in some Oracle data and SAP data, but we got stuck into the automation. And then once we bring in the data, we'll figure out actually what to do. So there are many such initiatives that are happening because there is a push, there is a pressure, there is an awareness that they have to do something with your data. There is a big opportunity. Now we see that there are two approaches to it from a digital technology perspective. There is a platform approach, there is a point application approach, and they are not distinctly different. When we talk about performance, it is essentially cross-functional. Every performance parameter, whether it is a maintenance alert or is it excess oxygen in your furnace, if it is an extra working capital tied in your inventory, has effect into your every other function. So essentially, it's a cross-functional. You can't really deal with it in isolation. And that's why you need a platform. So how we are going about the platform? So we are not really talking first when we are actually putting a platform in place. We are not really talking about that whether we are dealing with maintenance or whether we are dealing with finance or HR, and we have also done legal compliance. We are saying that there has to be a way of harmonizing the data. There has to be a very simple way that I want to trend my sulfur content in a crude run, the change in corrosion if I have got a pharmacense sensor, as well as the maintenance cost when I'm running this particular kind of crude on a simple trender, and they should be able to I should be able to roll up and drill down based on a common hierarchy. So this is actually what we call a harmonization. So obviously it is a harmonization of the metadata, where there are different hierarchies, there are different naming conventions, there are different semantics, and this is actually a core part if you want to do digitalization and take a platform approach. Then all this actually comes to something we call digital twin. And this digital twin has a raw data, your level, temperature, blah, 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 and also has its KPI. That what is the inventory turns, how much inventory is attached in dead stock, blah, blah, blah. So there are raw data, there are actually KPIs and KOPs, and we are talking about now of the KPIs and KOPs, and this is where the predictability comes into place. It's not about predictive maintenance. Actually, we want to see also some key values and KPIs 10 days later or 10 months later. So this is what we think is a digital twin, where it actually brings your data into a context, and this is what needs also a lot of domain expertise. So as a technology vendor, we are building tools for building the twins, and then we are working with the domain experts, mostly from our customer, to create the real instances of these twins, right? Then there are hierarchies. The tank actually is not only the concern of the terminal manager or the inventory guy or the PSIST manager. It's looked, sometimes the finance manager wants to know how much inventory is there. So there are different hierarchies, there are different paradigms. So these aggregations are not fixed in a company. So how do you handle that? Because without these aggregations and supporting these different paradigms, you can't handle you can't bring the context. So when we marry this, actually this becomes the contextualization of digital twin, right? And I will elaborate this a little bit later. Now what happens that if I'm saying there is a platform approach, is there a place for specialized applications? For us, the answer is yes. That you will definitely need a very specialized simulation tool, a predictive analytics tool, and this and that. But then it has to come into context through a platform, because otherwise it's another point solution, probably using the most advanced AI and analytics technologies, but that actually has a very limited effect. So definitely the role of specialized applications will be there, but then the best way to go about is bringing in the specialized application is through a platform. Because the specialized application will probably, if it is a specialized maintenance application, will be a perfect tool for your maintenance department. But for bringing it into the context, you will need this data, the events to come through a platform. Then this another part is that when you have a specialized simulation tool you want to bring in, the entire process of pushing in data there and bringing out the results and bringing into a context is highly manual. And the process is manual because there is a lot of vendor lock-in. You can't get access to the data, it's not cleaned up, the metadata is not clean, the hierarchies are not clear, the semantics are different, right? So the platform actually also has to work as an orchestration tool for pushing data to your new specialized super hi-fi predictive and prescriptive maintenance and bring out the prescriptions or predictions back into the context, right? And this is what we think is a platform that the industry needs for digitalization, right? And this is where we are building a platform where we are supporting open APIs. We are not trying to lock in your data. So you can actually get the data at a raw level, at any point of aggregation, any events that's worked out, anything. Right? Now, I'll give you an example why we say it is contextual, and this is from one of the projects that we worked on. And once we saw a KPI that the emergency purchases were $150 million. Right? This is simple KPI, emergency purchase, $150 million. And then they found out that there are tons of purchase requisitions. So there are a lot of purchase requisitions and purchase orders pending. So they started discussing with the purchase guys, and they said that even if we actually issue the purchase order, it doesn't help because the vendors are not supplying, because we have not paid them, we don't pay them. So ultimately, it's actually a vicious circle. It was actually a cash flow management and a working capital management that pushed the vendors to a 90 days payment terms, and then not paying unless and until they are really chasing like mad. And that actually is a root cause coming back and showing up, manifesting itself as emergency purchases, because when a turnaround comes, then you can't really wait for the mercy of the vendor. So you actually pick up the phone and start buying things. And this is a vicious cycle. So if you optimize your working capital in isolation, or you optimize your maintenance in isolation, they actually bite you back from some other angle. So it's a vicious circle. So the entire thing actually is cross-functional. You can't really digitalize in isolation. Right? Now, this another point is that you can't wait for all the requirements to be gathered and all the applications to be in place to start digitalization, because you will add new applications, there will be tags added every other day, there will be requirements coming in every day. So the platform actually has to be adaptive, that if there is actually a new data source being added, probably you brought in a sophisticated application for your turbine and compressor, then it adds an attribute to your digital twin. You don't have to start a new digital project for this, right? And this is something fundamental, that you will be adding tags or deleting tags, bringing in new furnaces and new tanks, or adding. So the atmosphere, the environment is highly volatile, and the platform has to accommodate that. You can't really make it like an IT platform that's done and dusted in one time, and any change is a new project, right? And you start with, okay, tell me what exactly you want, give me the requirement, final requirement, and then I build it, and no changes are allowed. Changes are part and parcel, and as you actually roll out anything, the changes start coming in. And that's actually, once you roll out anything, the changes start coming in, and this is where the requirement get finalized. So this is essential for a platform to accommodate these changes, right? So another part is that I talked about tag, addition and deletion tag. Suppose you actually take out a tag, or bring in another full tag. Do you have to really re-engineer the platform? Actually, it should not be. If there is a new tag, it will show up in your visualization or in your data model automatically, and that's possible. That's not a rocket science. But most of the people don't realize that this is the fundamental and core part, that whether you are adding a data source or a new tag is being added or a new asset is being added, that can be provisioned or instantiated automatically into the system. And the platform, the essential role of the platform is that. Now once the data is there, the infrastructure is there, you can put any kind of analytics on top. Maybe descriptive, and people actually today do not talk about the descriptive analytics. It's actually a very essential part. You are flying like an aircraft, so if you do not have your dashboard and how it is flying, you are actually losing a lot of money, right? So the descriptive analytics, especially in real time within the opportunity window, is actually very important. Then comes the predictive and prescriptive. So this is how I explain the causal context, that supposing there is an alert from a predictive maintenance system, and maybe the best predictive maintenance system that you have, It may not be coming from the platform. But it is orchestrated here, and this is brought in context here. And the supply chain guy may actually have a different context or different questions in his mind. And this is how he will drill into his world and see that whether it has an impact on demurrage, or demurrage is a better option than quality giveaway and this and that. The plant manager will have a different set of questions in his mind, right? And he has to actually drill down to his, through his paradigm, and will, need answer from a completely different set of questions. So this is what we call a contextualization. That analytics is fine, the data is fine, but then they have to be actually, in order to be meaningful, they have to come into a context, right? And then it has to be structured in a way that it actually goes and covers the entire enterprise. This is not a point solution handling maintenance in this plant and the other plant is different. This has to be actually something which can cover the entire enterprise. And when you acquire a new company, because when we work with our customers, the company structure is volatile. Sometimes they acquire a new company or divest another company, right? So there has to be, the platform has to have provisions for really bringing in another entity and rolling out the code to the entity without much fuss, right? And then you should be able to roll up all your key parameters like working capital tied into inventory at the top level and drill down from there all the way down. So the main issue is obviously it has to be enterprise-wide initiative. You can start small, you can start with one CDU train, you can start with one refinery, or you can start with one section of the plant. But the vision has to be enterprise-wide. What we call a concept of core, which we can discuss separately. And then it's very important that it is the value of information within the opportunity window is very important, right? If a mosquito bites you and it's malignant malaria, analysis after the patient is dead is no value or not much of value. So the entire thing, actually the discussion around analytics is about post-mortem analytics, right? Here actually the value is in knowing that within the opportunity window when this malaria or the malignant malaria can be treated. So if there are things going on in the plant and there are signatures developing of a disruption or an excursion, then the stakeholders has to know, right? And the stakeholders, as I mentioned, that could be a supply chain guy, could be a plant manager, could be somebody else. A maintenance alert, the stakeholder is not only just the maintenance guy. Now, what are the barriers that we see when we do such projects? The first barrier, and technology actually is a list of the problem. Because today, if you have got an iWatch, you know that the iWatch is about 100,000 times more powerful than the AGC, the Apollo guidance computer that took men to moon and brought them back. If you actually, there are a lot of articles on that. So the technology is not a challenge today. That amount of computing power that you have, you can actually churn every data in every other way, right? And that too in real time. So technology actually is not a challenge. The challenge, what we see, is data lock-in by vendors. Most of the time we spend actually getting access to the data, because there are a lot of fear of God that if you touch my ERP, things will sky will fall apart, right? Another thing is the fear center. We have seen actually a lot of resistance at the working level, because we all know that people have been massaging data and preparing handcrafted reports. And once you put such a visibility on top, then a lot of past history becomes visible. And here is a role of leadership to mitigate this fear. And we have seen projects which are highly successful where the leadership actually mitigated this fear of getting exposed. And we have seen actually people kind of kill the project by a very slow ping pong, because the leadership didn't have to address these issues. And definitely there are power centers in every company that you get the EPSIST data and I control it. So if I actually automate all the analytics and all the report and all the morning reports I'm submitting, then I'm losing power. My entire control and the existence is under threat. So there is a lot of power center. So these are the three issues actually what we see, and technology is least of the problem. And this is what I explained, that this is what are from the real projects, these dialogues. And very quickly coming to the impact, this is a KOP, this is a KOP we have done for a CDU, for a 300,000 barrel refinery. And the potential impact just from one KOP, this is a predictive and prescriptive application. We are actually suggesting an ideal value at every crude change. I don't want to name because use case also has a lot of value. The customer confirmed that if they can actually achieve the optimum value at half the time, which is highly possible, then the bottom line impact is about $500,000 to $300,000, depending on the price of the crude. If we calculate all the KPIs and KOPs, I put a very conservative number here, $100 million for a mid-size or a mid to large refinery. But if you think of just energy cost of a 300,000 barrel refinery and taking all your energy, utility, fuel and loss together, you will see this is actually sometimes 8 to 9% for a complex refinery. And if you do a back of envelope calculation, just 1% improvement in energy is about $5 to $6 million, right? So the impact of unleashing data through a proper digital platform could be enormous, could be actually hundreds of millions of dollars for any plant. And just for energy, maintenance, catalyst, probably three big costs in refining, because I see engineer guys in front, so I'm sticking on to this for refining. You see that energy could be very easily $5 to $6 million, 1%. Maintenance could be actually $2 and $2.5 million. If you increase on catalyst, probably it's, if you actually use the catalyst in a little bit better way, probably it's $1 million per year. So just a few things can justify the ROI on any digitalization initiative, and the overall impact, if it is done properly and rolled out enterprise-wide, could be hundreds of million dollars. So I think I have to stop here. I probably ran out of my time.